Okay, so now this is another video for alligation. Okay, so suppose that we are given some unit values for some mixture. So last time we talked about if we take cement and sand and aggregate. So we have a mixture known as concrete mixture. Now suppose now that the first value is 200 for the cement, second for the sand, and the third 50 for coarse aggregate. So now, if we know the price, the unit price or the unit value of the mixture, concrete, and we know also the unit values for the components, concrete, cement, sand, and the aggregate. So we have to find the ratios between ratios of quantities we can mix, ratios for cement, sand, and aggregate to mix in order to find a mixture with this value. So it means we need to find the ratio omega 1 over omega 2 over omega 3. In other words, we have to find the weights for each component. So now, last time we said that if you have such a situation, we have infinitely many solutions. So this is what we are going to see. So it is because this is one equation, and three with the three unknown. So it means that if you have one equation with three unknown, omega 1, omega 2, omega 3, it means that we must have two parameters. We fix omega 2 and omega 3, for example, and we compute omega 1 in this case. But other way of doing it is to use another method in order to solve this problem. It is customary known that there is an appropriate method which is associated to this problem. Now the solution is we have many solutions, especially omega 1, omega 2, omega 3, with some parameters which are positive in order to avoid negative weights, because these weights are usually positive or equal to 0 if we want, but mostly greater than 0. Now, last example, we have a solution like it was 1, 2, and 4. So how to find that ratio? It means for a quantity, relative quantity 1 for the cement, relative quantity, other relative quantity will be 2 and 4 for 2 for sand and 4 for aggregate. So in this case, in order to find this one, we can substitute. For example, if we substitute value x here equal to 1 and y equal to 4, so we're going to find this result. So I'm going to check this one before I continue. So omega 1 here is equal to 31 times 1 plus 15 times 1 is 30. Times 4. it is 60. And then numerator, 5 times 1 is 5. 2 times 4 is 8. And then we have 13 out of 91. So which is, 91 is a multiple of 13, which is 1 over 7. Okay, so omega 2 will be something over 91. So no change. So numerator, we have 26 times 1 is going to be 26. So this is like 2 over 7 after simplification. And then here we have 13 times 4 is equal to 52 over 91. Okay, so this is after simplification, we get 4 over 7. Now, in terms of ratio, so omega 1 over omega 1 over omega 2 over omega 3. Omega 3. So it's going to be 1 to 4 in this case. This is the ratio that we saw last time. But if we change, suppose let me change values of x and y here. I'm going to get other values, other weights. Suppose I change here, for example, and suppose let us put 1, for example. Okay, so in this case, what I'm going to have, omega 1, the first weight. For the sand, for the cement, it's going to be 5 plus 2. This is 31 plus 15. So it's going to be equal to 8 over sum of these is 46. Okay, now omega 2 is going to be equal to something over 46. And numerator is 26 times 1. So omega 3 is also something over 46. Now 13 in this case. Now, if we get the ratio, so we find another ratio. So we find another ratio which is not necessarily this. Another ratio we can find ratio omega 1 over omega 2. So it's going to be equal to 8 over 26. And if I try to put all of this on the same denominator, it's gonna be 8 and then 26 and then 13. So upon simplification, division by 2, no, by 13, no, it's not possible. So I can get this ratio, no problem. We have 8, 26, 13 in this case. Okay, so now we can have so many ratios. So now here, let us verify if for a different ratio, let us verify if we take the mean value, if we get 70. Okay, that is what we can check. We have 8 over 46, sorry. I have this situation, 8 over 46. Now we calculate the mean value and check if it is equal to 70. So it's gonna be equal to omega 1 P1, omega 2 P2, omega 3 P3. So this is 8 over 46, and then plus times 200 over here, plus now 26 over 46 times 45 plus 13 13 times 13 times divide by 46 times 50. 50 is the third unit value or unit price if you want. So I divide all of this over 46. So I'm gonna have 1600 plus now 26 times 45. Gonna have like 30, 64. Into 4 is 24, 27, and 90. So summing up 711. So 1170. I have to add 13 times 50. So 13 times 50 is 650. So 650. So now I'm gonna have, in this case, 1170 02171. So I have to add again 160 0 1 2 1 3 3. Okay, so now this value 23320 have to divide by 46. Now I have to find 3320 divide by 46. Is it correct if I put 7 times 6 42, 7 times 4 28, and what do I have here is I have 3 2. Where is the mistake? Probably I think that we have a mistake. We have to check this 1170. Let me check again. What is the problem? So here it will be 0 12 1 6 plus 1 is 7 and 1 I have 8. So now here we have it is no longer this, it is even higher than this. It is 4 then 3, much bigger than what I had before. So I have to check on this one. I have to check 2 times it is 90, so 24 plus 3 27. I think this is correct. 1170 here, so I have to add this, so I get 1820. So I think this is correct, and adding up I have this, so I have to divide by 46 7 6 42. I carry 4 7 4 28. That is 3 3 3 2 2. So so I don't know what is wrong here. I think that somewhere I have a mistake. Maybe what do I have to check for? To check for this value. I think 7 times 5 times 1 plus 2 times 1. Here is a mistake. I think I have found a mistake here. This is not 8, but it is, what is it? It is 5 times 1, 2 times 1, and it is 7. Now here the ratio should be 7, and so let us correct ourselves. So this is 7 times 2 is 14 instead of 16. I was wondering why. The answer was incorrect. Let me use a different color now. So here, instead of this is correct. This is what was not, and this is instead, yeah, that's correct, and it is 4 here. Now when we add it up, it is 2 and then 3, so that is 3, no, 2, sorry. Okay, so division result into 0, then 70. Then we have with a different color, it is going to be the sum 322 over 46. After division, you get 70. Okay, so which means that our formula is correct. We can also check for a different value. Suppose we take a 2 here and 1 over here. If we take x equal to 2, what will happen? Okay, we can expect all of these ones to be different. Now this is if it is 2 and y equal to 1. So we're going to have 5 times 2, 10. 10 plus 2 is 12. So I hope there is no mistake again. So now here we have 62 plus 15. 62 plus 15, which is going to be 12 over 77. 77. So everything here also 77 over 77. All right. Next is to count 26 times 2. It's gonna be 52. So 13 times 1 is gonna be 13. Okay, very good. So now next we're gonna check again. We're going to check that the weight, so formula is the same. So what is going to change the coefficients? Omega. So all right, so now what we have here is so omega. So let me just use a different color. So of course we are not expecting this. This is going to be 12. This is 52 and this is 13. Okay, this will be 12. 5 times 2, 2 times 1, 10 plus 2, 12. Then 12 to 52. Because 26 times 2, in the case x is equal to 2, then 2, 13. Okay, so now the weights. Now we have the first weight, second, third. Substitution, we have 12 over 77 times the first price, 200, plus c, omega 2 is 52, much bigger than before. So 45. So plus c, now 15, no, 13, 77 times z, times z 50. Okay. All right. So now common denominator, of course, is z 77. Now 12 times 2, 24, 00 plus c. Now again 45 times 52 is going to be 95. I carry 2, then 22, then 0, 4, 23. This is 23, 4, 0. I'm gonna have to add 6, 5, 0. Okay, so adding up 2, 4, 0, 0. I hope it is correct. So we're gonna have 4, 7, 4, 0. We have 4, 7, 4, 7, 4, 0 plus 6, 5, 0. It's gonna be equal to 09315. Now what I have to do is to take 5, it's going to be 5390. I divide by 77. I'm dividing by 77. I'm gonna suppose I'm expecting the answer to be 70. Let me put 7. 7 times 7, 49. I carry 4. So 7 times 4 is 49. Sum is 53. 53. And then I have 0, which is also 70, what I was expecting to have with another ratio. Okay, so now this is the problem. This problem is actually alligation alternate. It is the alligation alternate problem, in which only prices are given and the expected price is also given. Now we are looking for ratios. Those ratios are given by the if you know weight, so ratio is just ratio of this weight, omega 1 over omega 2, omega 2 over omega 3. So these will give you the ratios, especially numerators will be ratios, which means you have a ratio like this: 5x plus 2y, 26x, 13y. So if you take this quantity, the quantity of the first quality cement, this quantity of the second quantity, fraction of it actually. So we have so and so on for the third. You will get a mixture whose price or whose unit value is 70 per unit of your quantity. So now the one problem here is, how do we find such a solution? Okay, here the solution is not unique in the sense that we don't have only this form. We can have other form, but each one can be a function of two values, x, suppose x and y, which are strictly positive, and not necessarily the same coefficient as we have here. We can look for other ways in which we have different coefficient here, as you have here. But this is one of the solution which gives the opportunity to have all other other weights, infinitely many. We have infinity of weights, 3 weights. If we take arbitrary values of x and y. Okay. So now to solve this problem, how do we get how to get a solution like this? What method is used? Method. Let us write it. Method here. The method. So the method which is used here is the partial mean value method. Partial weighted mean values. So it means that the mean value is considered as a combination of this, a combination of this partial weighted mean values. Let us call it pi, for example, pi bar. So how do we do it? So we group these values p1, p2, p3 into into groups. We group them such that there is a group which is greater than the mean and a group which is whose values are less than the mean, in order to avoid the negative weights. So we have, for example, a group P2 and P3. These are groups whose values are less than the mean value. So 200 is greater. It is the only one which is greater than the mean value. Mean value here is 70. Okay, so now what we do now, we look for partial values. So between, for example, the first one and the second on one side, and on the other side we take between the first one and the third one. And here we can call it the first partial fraction, and here the second partial fraction. And then now what will be the mean value? So mean value is going to be equal to the combination of those two by using some weights. Now how to find how to use this method? Okay, so we first consider this mean value as the mean value of the first two and mean value of the first and the third. And then we determine some coefficients. So of course we will have one question with two unknown here, one question with two unknown. We have one question with one parameter, for example, parameter x. And here we have one question with parameter y. And then the combination of these two will give a mean value with the two parameters. In each case, we will have those values. Okay, so now keeping in mind that we know the values of P1, suppose P1 we know it is 200, P2 we know it is 450, 45. So P3 is 50. Okay, and the mean value, of course, the global overall mean value is 70. Okay, let us skip this one and look for the method. We call it we call it partial weighted mean values method. Okay, let us describe it as here in order to get such a solution. This solution, how we can get it? By using this method. Okay, so here we can combine the first one and the second in order to get this one. So this one, the first partial weighted mean value will be some weight 1 P1 plus 1 2 omega 1 2 P2, for example. So on the other hand, the second partial weighted mean value with the I here, I can write I here extending from 1 and 2, some index. Okay, so now here we have another weight 2 indexed like 2 and let us take 1 because it is associated to the first unit value, omega 2 3 because it is associated with P3. Okay, in this case these are normalized weight, which means that the sum of them will be equal to 1. Also sum of this weight which are normalized is going to be equal to 1 also. So in this case there are different ways of because it is one equation with two unknown, so we can set one unknown as a parameter and find other and so on. But another way of doing it, first we can one way of eliminating parameter is to associate this one, this weight here, to 1 P1 equal to omega 1 1 P1 omega 1 2 P2, and then because this is 1 and we have equation like if you put this in second member we have 1 1 P1 minus P1 bar is equal to just plus omega 1 2 factor of P2 minus P1 bar. Okay, in this case, so we can, this must be equal to 0 on one hand. On the other hand, we have also omega similarly. So let us do it like this in order to show how we obtained it. 2 1 plus omega 2 3 factor of P2 bar, which is equal to something like omega 2 1 P1 here plus omega 2 3 P3. Okay, P3, P index P sub 3. Okay, now also in the same way, 2 1 factor of P1 minus P bar 2 plus omega 2 3 P3 minus P2 bar. Okay, so now this must be result into 0, must be equal to 0. Now, in order to eliminate one parameter, we can use ratios. We divide both sides either by the first weight or the second. And in doing so, we are going to get, if we divide both sides by omega 1 1, omega sub 1 1, similarly, omega 2 1 here, omega 2 say 2 1 again. So we can find the value of this ratio. Let us call it R12. This is R23. For convenience, we take the sub indexing of the numerator R1, this ratio, R2, R sub 2, 3, for example. So in this case, we can find first ratio. This one is going to be equal to negative P2, no, P1, sorry, minus P1 bar divided by this one, P2 minus P1 bar. Okay, this will be the value. Now, similarly, R23 is going to be equal to opposite of this one, P1 minus P2 bar, and over P3 minus P2 bar here. Now, but we don't know the value of this partial weight. We don't know them. but as the overall mean value p bar can play the role of this partial one because it represents them. So this is the reason why we can substitute with here p bar equal to p1 bar in order to get the first ratio to negative p1 minus p bar over p2 minus p bar, what we have. So doing so, we have 200 minus 70 divided by p2. P2 is 45 minus 70. So associated with a negative sign here. So we got R12 is equal to 130 divided by 25. So by simplification, we get 26 over 5. So that is the first ratio. Now, this second ratio here, we suggest under the same condition, but with the second partial weighted mean value. Second one, this brings us to the value of the second ratio. So gonna be p1 minus p bar over p3 minus p bar, and which is actually going to be 200 p1 minus 70 over p3 is 50 minus 70. So now results is gonna be equal to 130 divided by 20, and by simplification 13 over 2. This is the second ratio here. Okay, so now you can see some numbers like some relative weight 26, some relative weight like 13. Now let us continue again. Now we come back to this since this equation is equivalent by using this on here, if we divide both sides by W11, W12, W11, W12, no, 11. In this case, what we get here is, okay, maybe this is not, it is out of the vision field. So we can just replace this equation by its equivalent value on this side, and we're gonna have something like 1 plus R12 factor of P1 bar equal to P1 plus R12 P2. Okay, something like this. On the other side, similarly, we'll have for the second weight, we'll have 1 plus R23 P2 bar is equal to P1 plus R23 P3. Now substitution with the corresponding values. So we are going to get 1 plus ratio 26 over 5. So times P1. So this is equal to P1 plus 26 over 5 P2. Here 1 plus 13 over 2 factor of P2 bar, P sub 2 bar. So P sub 1 plus 13 over 2 sub P sub 2, P sub 3. Okay. So now now we can have this one. We can multiply by 5 both sides, we get this one will result into 31 P1 bar equal to 5 pi 1 P sub 1 plus 26 P sub 2. This result into 15 P bar sub 2 equal to, now multiply both sides by 2, we get 2 P1 plus 13 P sub 3. Okay, now we have multiplied both sides by a non-zero constant, both sides. So we can, in both cases, but we can continue in the same way, multiply by any value, like here x, and here by y. It is, so the ratios, the weights will not change if we multiply by any arbitrary constant. In this case, we are going to get, here, we get 31x p1 bar is equal to 5x p1 plus 26x p2. Now, on the other side, we will have 15 y p2 bar minus, equal to twice y p sub 1 plus 13 y p sub 3. Okay, so now we're gonna have, in this case, what do we have to do here in this case? So in this case, we can add them up, add this equation and this equation side by side, and we're gonna have, as a result, let me use this one. This is 31 x p1 bar plus 15 y p2 bar. Now it's gonna be equal to 5x p1 plus so this one and this one together, 2y p1 plus now this one 26x p2 plus now 13 y p3. Okay, so now this is the same as we can put this is a factor of p1, and we get finally 5x plus 2y p1 plus 26x p2 plus 13y p3. So on one side, on the other side, we have the partial mean values, partial weighted mean values, p1 bar plus 13y p2 bar, or p sub 2 bar. So now from this, now as we said before, this weight, I mean this value, this average value will be the average of these two, meaning that it can represent them as we did before in order to find the ratios, these ratios. Okay, so in that, in the same way, so we can substitute the value. Here we can substitute, this value, its role can be played by the overall mean value, weighted mean value. So we have 31x plus 15y times the same weight. So this is going to if we solve for p bar, so we have here 5x plus 2y p1 plus 26x p2 plus 13y p3. Okay, in that case, it is clear that we can solve for the overall weighted mean value. By doing so, what are we going to have? In this case, we're going to have the relative weight of the overall average is at 1x plus 15y. Now this is relative weight of the overall weighted mean value. Now the weight of the first component, the first price value, P1, plus the weighted relative weight, 26x for the second, and 13y for the third value. Now it is clear that if we divide both sides by the common factor for the weight of the overall weighted mean value, we're gonna have this situation, x plus 2y divided by 31x plus 15y, p1 plus now 26x over 31x plus 15y, now p2, now p3, 13y over 31x plus 15y, p3. Okay, so now as the original expression of the the average value, so this will represent the first one. Let me use this one. This one will be the first weight. This one will be the second weight. And this one will be the third weight. So now for two parameters, positive one, strict one, we have solved the problem, and the ratio, as we said before, the ratio will be 5x plus 2y to 26x to 13y. Okay, so this brings us to the end of this presentation about the problem of alligation alternate, in which once we know we desire a certain average value for the mixture, so if we know the individual unit value for each components of the mixture, what will be the ratio to be taken in order to get that desired weighted mean value? So you see that there is infinitely many possibilities of finding, depending on infinitely many possibilities depending on here the value of x and the value of x and value of y. We can arbitrarily take any value provided this parameter is strictly positive, as we said at the beginning of this video. So thank you very much for watching this video. So next video will be now another method. This is not the only method that can be used. So next time we're gonna be using other methods which are based on the fact that these weights 1, 2, 3, and so on can be in general be calculated by using some partial or fraction instead of this overall fraction. So if we take the first weight over 2, we know that ratio, and the second to the third, if we know those two, and it is very simple to find the weight associated to those ratios. So until next time, please keep watching. Thanks.